I'm going to be looking at what computational thinking is and how this should be taught. There are many developing definitions that coexist, but I am going to focus on computational thinking as a means to develop problem-solving skills whilst applying computer science techniques. This idea was first proposed in 1996 by Seymour Papert. Progress in computer science and thinking became mirrored in ideas for solutions to problems and pedagogy theory. Many of the skills involved are familiar within the primary classroom. Berry defines computational thinking as looking at problems or systems in a way that considers how computers could be used to help solve or model these. Berry outlines 5 main concepts to explore when defining computational thinking, which are algorithms, abstraction, decomposition, patterns, and logical reasoning. There are alternative definitions, but I am focusing on these as they depict the value of problem-solving skills. There are other concepts that come under computational thinking, however it can be argued that these are not independent aspects, but rather derived and extended approaches of the main 5. The first concept is algorithms, which Wing defined as a process that takes inputs, executes a sequence of steps, and produces outputs to satisfy a desired goal. When pupils are taught how to implement algorithms for set tasks, which if executed correctly within a clear thought process, the algorithm can be followed to achieve outcomes efficiently and successfully. I saw this during my practice when the children wrote their own fruit salad and smoothie recipes and then followed each other's to select ingredients and make the products. Tasks such as these can be presented in relevant contexts that promote understanding and why people decide on particular methods. This is supported by Wing, who states that computational thinking describes the mental activity in formulating a problem to admit a computational solution that can be carried out by a human or machine. Abstraction is another essential key concept of computational thinking, which involves being able to utilize abstract ideas in where we make use of the crucial parts of a system whilst ignoring the fine details, thus portraying an abstract image that is immediately understood without the need to process unnecessary details. In history or geography lessons, children can be shown that maps of locations that are not to scale display an abstract picture to present roads and routes without the elements of buildings and features. The notion of decomposition is also a very useful and practical strategy. Larger projects are best managed by decomposition by breaking down large tasks into smaller ones. This approach to problem solving can be used in class activities like planning parts of a story in literacy, solving complex calculations in maths, or presenting a play in drama by recognising what is required, such as scripts, costumes, props, and a venue. Patterns convey a sense of similarity or reoccurrence. For instance, in computer programs, we can help children develop an appreciation of how and why a particular program has been designed in a certain way, therefore providing a valuable insight into the creativity and construction behind the design. Programming languages such as Scratch, Kodu, and TouchDevelop make it easier to recognise and use patterns in making interactive stories, games, and animations. Barr and Stevenson convey how simulation, modelling, trial and error, and computer game designs teach computational thinking skills like abstraction. This involves evaluation and reflective processes central to creativity and computational thinking. Google's definition does not acknowledge the concept of logical reasoning, which I think is a vital part of computational thinking, as in order to solve problems, children need to learn how to think logically. Teaching logical reasoning enables pupils to think about cause and effect and how methodical steps can be followed to reach a solution. This correlates with Berry, who asserts that from making predictions in scientific investigations to using software and ICT, children develop their ability in making deductions from the information they have. During my placement, this was evident when the children were testing the reflective properties of different materials in a science lesson. The children used their process and evaluative skills to determine the results of their experiment. To conclude, the essence of computational thinking comprises of a rich set of problem-solving concepts that can be applied in work and life situations to determine solutions and in ensuring our performance is more efficient. It is used to innovate the skills we already use generally in an analytical and more explicit approach. Therefore, it is not anything new and is what we have been using throughout time, whether we realise or not. It is important to appreciate that we do not need computers to achieve this. These skills can be applied to any task that involves critical thinking and can be taught to enhance children's proficiency in finding solutions and develop their thinking across the curriculum. I will teach computational thinking by making children aware of the 5 concepts as they apply them in lessons and within school. Encouraging children to think of new ideas, problem solve, and be experimental using computational thinking can offer many opportunities due to its multifaceted nature.